Hydrogen chloride is a very important industrial chemical. It has a lot of uses. For example, it is a very important constituent in dyes, drugs, paints. It is also used for cleaning the surfaces of metals before electroplating, before painting them, and so on. Also, hydrogen chloride is used in making medicines. In some medicines, for the digestion of proteins. And it also kills some harmful microorganisms. So these are some of the uses of hydrogen chloride. Let's see how we can prepare hydrogen chloride in the laboratory. We can prepare HCl by direct synthesis. That is, when hydrogen combines with chlorine, it gives hydrogen chloride. We know the reaction that when an acid reacts with a salt, it gives another acid and another salt. This is what specifically we use in the laboratory to prepare HCl. Let's see the reaction. We use a salt, most commonly sodium chloride, that is made to react with sulfuric acid, and the temperature should be above 200 degrees Celsius. So one salt reacts with one acid to form another salt, that is sodium sulfate, and another acid, which is HCl. So in this case, we had to prepare HCl. So by using this reaction, we can prepare HCl. Let's see the experimental setup. So we take this experimental setup. This flask contains sodium chloride. We pass sulfuric acid in this. Then this vessel contains concentrated sulfuric acid. If there is any water vapor or moisture, it is absorbed by this concentrated sulfuric acid. The pure dry gas is made to pass in this vessel containing air. So let's see what happens. As we add sulfuric acid to sodium chloride, it is then heated. A gas is evolved and then it is dried. It passes in the last vessel containing air. You see that it displaces air. That means it is denser than air. So the gas, that is HCl gas, is denser than air. So it can remove air by the upward displacement. So we can collect the gas by the upward displacement of air, as the gas is denser than air. So this reaction, that is sodium chloride reacting with sulfuric acid at a temperature greater than 200 degrees Celsius, gives us another salt, which is sodium sulfate, and we can prepare our hydrogen chloride. So this is how we prepare hydrogen chloride in the laboratory. The reaction used in this case is one acid reacting with a salt to give another acid and another salt. Hydrogen chloride gas is heavier than air. Is it true or false? In the laboratory preparation of hydrogen chloride, we saw that the gas is collected by upward displacement of air. This means that the gas is heavier than air. So the given statement is true. Now we have to prepare aqueous hydrochloric acid. That is, we have to change the gaseous hydrogen chloride gas into aqueous hydrochloric acid. Hydrogen chloride gas is highly soluble in water. So we have to prepare the aqueous solution of hydrogen chloride. So if we take this setup, this contains sodium chloride and sulfuric acid. It prepares HCl gas. Now, if this tube passes the HCl gas into water to prepare hydrochloric acid in the liquid form, what happens is that HCl is highly soluble in water. So the rate of dissolution is very fast. As it rapidly dissolves in this water, there is a high pressure in this and there is a low pressure in the flask. As there is a low pressure in this flask, to equalize the pressure, the gas is sucked back in this flask. So now more gas is produced and the gas is also sucked back. That leads to the breaking of this flask. Let's see how this happens. So as hydrogen chloride gas is produced, it rapidly dissociates and dissolves in this water. But since the rate of dissolution is very fast, it is sucked back, and that leads to breaking of flask. This is known as back suction. Now we have to avoid this back suction. So to prevent the back suction of air, we use a different arrangement. In this, we take a funnel. This funnel provides a larger surface area for the gas to be dissolved. Now, as this provides a larger surface area, as the gas is produced, it is dissolved in water. Since it is dissolved at a very high rate, this creates a low pressure area over here. So as low pressure is created in this zone, to equalize the pressure, some water from this trough rises in the funnel. So as the water rises, the level of water here drops. That creates an air gap between the two. So now as more gas is produced, it pushes the funnel back as it pushes the water down. So the funnel again regains its contact with water. So let's see how this is happening. As the gas is produced, it is dissolved. Since it is dissolved at a very high rate, it creates a low pressure here, due to which water rises. As water rises in the funnel, that creates an air gap between the level of water and the funnel. Since more gas is produced, it pushes the water back, and so the funnel regains its contact with water. This prevents the back suction of water in the flask, hence preventing its breakage. So let's revise what is happening in this case. In this case, we have to prevent the back suction of gas back in the flask. So for this, we use a funnel arrangement. So first of all, water is taken in a container, and a small portion of water, there is a funnel which is immersed in a small portion of water. Now, since HCl is highly soluble in water, HCl dissolves at a higher rate than it is produced in the flask. Since it dissolves at a very high rate, this creates a low pressure area in the zone above the funnel. So what happens? As the gas dissolves very rapidly in water, there is a low pressure area in the zone above the funnel. So the pressure above the funnel decreases and the pressure in the trough is high. So to equalize the pressure, some water from the trough rises into the funnel. As some water rises into the funnel, the water level in the trough drops. Because of this, the funnel loses its contact with water. To equalize the pressure, some water from the trough rises into the funnel and the water level in the trough drops, so the funnel loses its contact with water. Now, as more gas is produced, it pushes the water back in the trough, and so the funnel regains its contact with water. So this is how, by using a funnel arrangement which provides a larger surface area, the back suction of the gas is prevented. And this process continues till the entire water is saturated with HCl gas, and hence we get hydrochloric acid. So by using a funnel arrangement which provides a larger surface area to prevent the back suction of the gas, we get a saturated solution of HCl gas in water. That is, we finally get hydrochloric acid. Now let's test HCl. HCl is a colorless liquid. So we have a chemical test. This flask contains ammonia gas. Now we'll bring the colorless liquid and we add it to this ammonia gas. Observe what happens. As we add the colorless liquid to ammonia gas, we see dense white fumes being formed. This proves that the colorless liquid is HCl. The reaction taking place in this case is ammonia reacts with HCl to form dense white fumes of ammonium chloride. So if we have a colorless liquid and we have to check whether it is HCl or not, that colorless liquid is made to react with ammonia. If we get dense white fumes, that is, we get the dense white fumes of ammonium chloride, it verifies the presence of HCl. This reaction, we can also use ammonium hydroxide in place of ammonia. So we add the ammonium hydroxide solution to HCl. Again, dense white fumes of ammonium chloride are formed and it forms water. So even if we add a solution of ammonia, that is ammonium hydroxide to HCl, we get dense white fumes of ammonium chloride. So this is a chemical test for HCl.